So the last lecture, folks, we're at the end line. I wanted to add a little bit more to 5.8. 5.8 was on the average value. So this is like 5.8 part B, average value. And we had seen that the average value was 1 over b minus a times the integral from a to b of f of x dx. So if our function is something like this, and we're integrating from a to b right here, there's some value where if I make a rectangle at that height, the area of the rectangle matches the area under the curve. This height is that f average. And let's say this occurs at C. Just because Dalton likes shit alphabetically. So C is NAB. So f average is f of C. If I call it f of C, this time we can tie this back. This ties back to the mean value theorem for integrals. The MBT for integrals. The MBT for integrals said, this was in 5.6. This said in AB, in a closed AB where f of x is continuous, there is a C such that the integral of f of x dx from a to b equals f of c times b minus a. That was our MBT for the integrals. And this is where we find the average. You see how close those are? Compare that to what we did with the f average. It's literally the same thing. All we've done is multiplied through by b minus a. So this is like a 2 birds, 1 stone kind of thing. I'm going to give you guys a little exercise to do with this. Because there's a problem like this on the exam. So if f of x equals x cubed minus 1 on 0 to, let's not go too big, 2. Find the mean value guaranteed, the C guaranteed by the MBT. And find F average. You can do it in any order you want. It's probably easier to find F average first, to be honest. I don't know, they're the same amount of work. And let me get you pointed in the right direction to start checking. We're on 0, 2, so that's my AB. So B minus A is 2 minus 0, which is 2. So F average will be 1/2 from 0 to 2, x cubed minus 1 dx. Which is your F of C. Okay, so we do that integral, what do we get? This goes up to x to the fourth and we divide by 4. And this goes up to x to the first, we divide by 1, which obviously doesn't do anything there, that divided by 1. And we're evaluating from 0 to 2. So I've got 1/2 2 to the fourth power over 4 minus 2. And then I have minus, remember, we do f of b minus f of a. So I'm going to do the upper one minus the lower one. 0 to the fourth power over 4 minus 0 to the first power over 1. Maybe I'll be clear with that. You can leave the constant outside at 1/2 and just apply it at the end. It might make things easier. So we
take out the
go ahead.
1/4 of the x to the power.
You could treat it as 1/4 x to the fourth, but if you factor out the 1/4 outside, you got to factor out everything.
Oh. Never mind. I didn't know.
I'll go over that in a second. 2 to the fourth is 2, 4, 8, 16. 16 over 4 minus 2 minus 0. Those are all zeros. 16 over 4 is 4. 4 minus 2 is 2. 1/2 of 2 equals 1. That is the average value across that integral from 0 to 2. To find the C guaranteed by it, well, f of c is this. F of x is x cubed minus 1. So f of c is c cubed minus 1. And that has to equal our f average. So I get c cubed equals 2. And then c is the cube root of 2. It's not necessarily a nice number, but it is a number. Anybody have a calculator with them, know what the cube root of 2 is? I know you don't know what the cube root of 2 is, but if you have a calculator with it. I hate pulling out my phone. I'm kind of curious to. Ooh, that's not the thing. $1.26. Approximately 1.26. So if I were to sketch x cubed minus 1 real quick. From 0 to 2, it starts off at -1, goes up to 7. But it's doing some stuff like that. Hold on, I'm fucked up. I'm doing this all crazy. That's not the graph. Let's try that graph again. It's just x cubed moved down 1. should cross at 1. There's 2. 2 should go up to 7 here. That's -1. That doesn't feel like that should be the average value. Huh. Maybe it is. So we're looking at this, the net area from here. Should equal the same thing as if we did a rectangle right here at 1.26. That's what's going on pictorially. Any questions? So to do the mean value theorem, you're just doing the integral normally, and then you multiply by 1 over b minus a. That finds the average value, and then it's easy to go from there. There's some other stuff we did in 5.6 before I hit 5.8 that I want to revisit now that you might have had a little time to do homework on it. In 5.6, we had the fundamental theorem of calculus. We had 2 parts. The first part was the integral from a to b of f of x dx equal f of b minus f of a. That was part 1. Part 2 was the derivative with respect to x of a to x f of t dt equals f of x. That's the one I want to revisit right here. So let's revisit number 2. Let's do an example. Fuck it, we just had x cubed minus 1. Let's do f of t equals t cubed minus 1. And we want to find the derivative with respect to x of 0 to x of f of t dt. Shortcut method, it's just f of x. That was our shortcut from part 2 of the fundamental theorem. Let's actually work out the integral though. You should put parentheses around it like that when you're doing integrals to make it clear what's inside the integral and what dt is hitting. If I integrate that with respect to dt, we just had this 1/4 t to the 4th minus t. And we're evaluating that from 0 to x. And then we have a ddx outside. So I've got ddx of 1/4 x to the 4th minus x minus 1/4 0 to the 4th minus 0. You know what? Fuck it. I'm going to go back to a. I'm going to use a here. I want to show that it's any value right there, not just 0. Let's use a. So this will be 1/4 a, and that's an a right there. That's an easy change. we can apply the derivative of to each of these groups separately. A is a constant. What is the derivative of a constant? Zero. The derivative of that is zero, so we just have this, which is we bring the 4 down, lower it by power, and then x goes, that was x to the 1, we bring the 1 down, we lower it to power x to the 0. This ends at 4 and 1/4 cancel, we get x cubed, and x to 0 is 1, and we get x cubed minus 1, which is f of x. So that's saying how the fundamental theorem will actually work out and showing that it's true. But there's a little bit that fundamental theorem doesn't show us. Let's redo this problem. Same f of x, so we know the integral. This time, let's do d dx of a to x squared. By the fundamental theorem, you want to say we want to just say this is f of x, which would be plugging in x squared, not necessarily f of x, but f of what's up here, f of x squared cubed minus 1, which would be x to the 6th minus 1. That's what we want to say. What happens if we actually work it out, though? We know the integral already is, and it's an easy one to do. We had 1/4 t to the 4th minus t evaluated from a to x squared this time. This is the derivative of 1/4. X squared to the 4th power is x to the 8th power. And then t is x squared. Then we have minus the 1/4 a to the 4th minus a. And pause, let that sink in. You pretend to write it. We end up with d dx of 1/4 x to the 8th minus x squared, which is 8 times 1/4 x to the 7th minus 2 times x to the 1st, which is 2x to the 7th minus 2x, which is most definitely not x to the 6th minus 1. So fundamental theorem gave us the wrong answer here. Because I used it wrong. It's all because I used it wrong. Can anyone see the difference between these two results? Two x to the seventh minus two x versus x to the sixth minus one. Yeah.
So like, exponent went up by one and the coefficient, so on.
Coefficient, well, let's say it doubled.
Yeah.
Coefficient went multiplied by 2. So we have it multiplied by 2. And the exponent going up by 1 really means we're multiplying by 2x. Right? So if I multiplied by 2x, I would get that. We started with this. Where might the 2x come from? The derivative of x squared. Good, Matthew. It was this. So the fundamental theorem says d dx of a to x of f of t dt equals f of x, but if it's not x up there, if it's some function g of x, we really end up with f of x times g prime of x. It's like a chain rule. One way of seeing it is introducing u equals g of x. So d dx of both sides. This is du dx equals dg dx, which is g prime of x. And if we write it in the other form, we have du equals g prime of x dx. So if I turn that into d dx of u, a to u, f of t dt, where u equals g of x, I do my f of x or f of u du. And this is f of g of x times g prime of x. And that's what would be here. I wrote f of x, that's wrong. That's f of g of x. Whatever was there, we plug in. Like we plugged in the x squared got plugged in. Tomorrow night at Friday Night Lab, they're doing the derivative B. I'm sure there's cash prizes. If you want to participate, if you've been gotten pretty decent at the derivatives, participate, you might have fun. You're probably going up against students with Calc 2 and Calc 3 who have had more practice, but it's still kind of fun. You could see Jose just asked which sections are on the exam. There's no Remont sums. The practice exam with answer key is up in the modules. Let me show it to you real quick. So you've got some integrating with indefinite functions. Then you've got some integrating with definite integrals. We're doing a problem like 6 in a second. 7 is like the Riemann sums, but you don't have to do the Riemann sums. It's just break it up into 4 rectangles. And you're doing Riemann sum work without doing Riemann sums. You don't need a Riemann sum formula. Like here it says, given the graph, estimate the net signed area bounded by the curve and the x-axis over 1 to 5. Use 4 rectangles, midpoints, and shade the rectangles. So you go from 1 to 5 and you will shade the rectangle. From like 1 to 2, the midpoint would be 1.5. You go up to 1.5, you make a horizontal line, make a rectangle right there. And you'll see it in that answer key. That part's pretty easy. Then you'll use the fundamental theorem to show how close you get. 5.7 is on there, the rectilinear motion. It's a simple problem of doing an integration twice. And number 9 is on what we're doing right now. The fundamental theorem of calculus part 2. Number 10 was that mean value theorem we just talked about. And showing it on a picture. I made the answer key for this in 15 minutes. This is much easier to review than the other one, and it's closer to the exam. Like that review for the last chapter, that was hard. Gave you good practice, but it's like too much practice. Too much algebra practice. I need to do that on chapter 1. Like really hit you hard with algebra on chapter 1. That way you go, oh shit, I really need to up my algebra game. Let's look at an example of this. What if we went the integral from, we'll do d dx of 1 to tangent x of t dt. The shortcut method says f of t equals t, and I need f of tangent x, which would be tangent x. And then I need f of tangent x times the derivative of tangent x. I'm sorry, not f of tangent x. I need tangent x times the derivative of tangent x. This should get you tangent x secant squared x. If you worked it out, you integrate t, you get 1/2 t squared from tangent x to 1. And then you're doing the derivative. This is the derivative of 1/2 tangent squared x minus 1/2 1 squared, which is 1/2. So it might be easier to recognize that that tangent, that square is like that. So we have to do a chain rule. We do 1/2 times the derivative of this, which is 2 tangent x. And then we just do the derivative of the inside. The derivative of the inside is secant squared x. And you will see when you multiply that out, we do in fact get tangent x secant squared x. You guys want to try one? I recommend working this next one out both ways. Do this shortcut and then work it out by hand. D dx of the integral of, let's do 1 to 1 over x. Sine of t dt. That should be the final result you get. So we do sine over the limit, and then we take the derivative of the limit. 1 over x is x to the negative 1. We take the derivative, we got negative 1 over, that becomes negative x to the negative 2. And x to the negative 2 is 1 over x squared. You did the other way. The integral of sine is what? It's negative cosine. Excellent. And we're doing that from 1 to 1 over x. And we still have a d dx. We have negative cosine of 1 over x minus cosine of 1. So we're looking at the derivative. The only one that's left after you take the derivative of cosine of 1 is that, which is sine of 1 over x times d dx of 1 over x. And you'll get the negative 1 over x squared sine of 1 over x. Using the fundamental theorem only speeds it up a little bit. If you work out the integral and do it the full way and then take the derivative, you're going to get the correct answer and you won't make mistakes. Well, hopefully not make mistakes. Chain rule seems to get a lot of students. All right, so we're going to take a 5-minute break. First, I wanted to show you something real quick. Dalton asked me, how can I figure out what I need on the exams? And so I showed him something and I misshowed him something. I didn't divide by 4 when I showed him. So I immediately wrote up the correct version, scanned it, and uploaded it. This is on the modules as well. But what you do is we have 4 tests, and 75% is test, 25% is final. So like this is the equation of your grade, the overall grade. Take 75% of the average of your test scores plus 25% of your final. That will get you your percent grade. Now, if you're trying to be above a certain amount, like say you're just hoping for a C, 70%, you can plug in 70 like I did down here. You know your first 3 test scores already, so plug them in. What I did is did 0.75 over 4 and you get 0.1875. I moved that out front. I effectively distributed and then moved all the things I knew were constants to the other side. You already know your score for T1, T2, and T3. The only ones you don't know are T4 and final. So if you want a 70%, let's say you had 80, 60, and 65, you plug them in over here, you work that out, and I got 31.5625. That equals 0.1875 of T4 plus 25% of the final. 0.1875 is 3/16. Because 75% is 3/4 times 1/4 is 3/16. So I just got tired of writing the decimal there, to be honest. So then you have two variables there. You have to do like a couple what if scenarios. What if I got this score on the test? This test on Tuesday. What do I need to get on the final? So like, let's say you got a 62 on the test on Tuesday. You plug that in, then you find out what you need to get on the final. If you got 100%, this is drastically going to change what you need on the final to pass the class. Now, if you're wanting above 70%, like you're aiming for an A, push that bad boy up to 90 and see if you can get a 90, above 90. Okay. That's how you would do that. And again, that's in the modules right here. So you'll see it. How do you calculate what you need on the exams? Let's take a 5-minute break. If you didn't get your last exam and you want it, I brought them in today. So if you'd like to come on up. Person I brought it. On that request. Yep. Alright, this section's on 5.9. It's doing U-subs with definite integrals. Let's just say we have the integral of 0 to pi squared over 4. Sine of square root of x over the square root of x dx. Straight to an example. Step 1, figure out the U-sub. Any ideas on what we could use for a U substitution here? Matthew says square root of x. Let's give it a try. We won't know until we try. I'll write that as x to the 1/2 because it's a little easier to take the derivative. So du equals 1/2 x to the negative 1/2 dx. So if I multiply by 2, I could write this as 2 du equals 1 over square root of x dx. I like that. I have that right here. That looks like a good choice, Matthew. I have 1 over square root of x and a dx. So this is the equivalent of 2 du. Step 2. Decide if you are going to keep u the whole way the whole problem or revert to x. After integrating. We're going to work out both paths right here so you see what the difference is. And on this test on Tuesday, you have a problem that says like do it both ways. So you can like do it both ways and make sure you get the right answer. If you get the same answer on both, you know you did it right. All right, so. Let's just rewrite what that integral would be. This would turn into 2 sine u du. With the integral, I'm gonna say a to b right here. Because what we decide to use for a to b is gonna change. If we're gonna go back to x, the path here is when you write the integral, but your integral is in terms of u, you very much need to say that these limits are in terms of x. And here we're going to do stick with u the whole way. If we stick with u the whole way, we need to reevaluate or rewrite the limits of integration. Using our sub, we had u equals square root of x. So when x equals 0, u equals the square root of 0, which is 0. When x equals pi squared over 4, u equals the square root of pi squared over 4, which is pi over 2. And our integral here, using our new limits, would be 0 to pi over 2, 2 sine u du. And now I don't need to write that the limits are associated with u. The integral is always goes with the variable in the du. The differential, the du. This one, if once you've done the substitution, is actually, I think, easier. We saw sine was cosine or negative cosine. So this is negative 2 cosine of u, evaluated from 0 to pi over 2. Oh, yeah. I assume, Jose, you were answering my question, what we should use. Now we go back to the other one. The integral is still the same. We've got negative 2 cosine of u, evaluated from x equals 0 to x equals pi squared over 4. Now I got to go back to revert to x. Negative 2 cosine of square root of x, evaluated from 0 to pi squared over 4. Yeah, Justin.
Or sticking with you, do you want us to show us the work of how like we took the square root of x, or can we just go straight to
You should write this part. I should see that on your paper.
Okay.
You should want to put it on that paper, because if you do it wrong, then I at least know what the fuck you did. And I know where the error is. Like if you said the square root of fucking 4 was 3, and you used 3 the rest of the way, I know you just fucked up your calculator work, or that's not even calculator work. Square root of 4 should be head work. But you made a mistake, and the answer was an arithmetic mistake, not a calculus mistake. If you don't show it and you're wrong, I would say let's ask Cohen how well that works out. That was throwing Cohen under the bus right there. Cohen likes to skip steps, and he pays the price for it on an exam sometimes. He said not well. But Cohen's gonna work on that, right? You're gonna start showing all your steps and shit. Make Hefe proud. Gotta untrain you from all that shitty high school, whatever the hell they taught you in high school. Sometimes being good at something makes it feel tedious to show the work. And I think Cohen knows what he's doing most of the way, but he makes mistakes and it pays. Oh, I could finish this out. This one takes a little more work, like cosine square root of pi squared over 4 is, you got to do it there. This is 1. So you're gonna have to do this shit at some point. There's no going around taking the square, like I didn't write it here, but the square root here was 0. Now, having a 0 in there and having it one of the things and it didn't change made that easier. But sometimes, like, there's more work going on, and you're good. Notice we still had to do this step. Still had to be done. If you do it right away, as soon as you switch limits of integration, or as soon as you do the substitution, switch to u, then you don't have to worry about remembering to go back to it later on. If you take the left path when you do it, you very much run the risk of forgetting to go back to square root of x, sticking with u and plugging in 0 and pi squared over 4. And then you would have said, I don't know what the hell cosine of pi squared over 4 is. You know what I mean? Sometimes you know what it is, and so it makes it even easier to fuck up. But you can do it 2 ways. Let me give you guys one to try. Try both ways on this next one. Is there any questions on this? Not a big step over the definite integrals. Just remembering that doing a substitution edits it a little bit. We're going to go from e to e squared of natural log of x over x dx. And I recommend working that one out both ways. Let's make sure everyone's on the same page. What should the use of be? Anyone get a working use of here? Let's take a look. If u equals the natural log of x. What's the derivative of natural log of x? 1 over x, yeah. And we do have that. Because you can rewrite that as ed squared natural log of x times 1 over x dx. So if you're stuck there, go ahead and keep going. You want a real mind fuck? I just thought about this right now. When I was your guys' age, we didn't have cell phones. Just fucking process that for a second. Not the fucking shitty phone that all it did was make phone calls, not even text. Nothing. We didn't have shit. A cell phone was a car phone. And they were fucking in like Lexuses and shit. They were expensive. Your fucking Toyota didn't come with a car phone. A Beamer came with a car phone. That ain't that fucking long ago. It really isn't. In big picture thing, we went from no cell phone technology to fucking video conferencing across the world with multiple people at any fucking time in like 25 years. That's crazy. About that shit. That's fucking crazy. Can't even fucking imagine what it's gonna be like 25 years from now when you guys are my age. You're gonna be like, I remember when I was a kid, we were stuck using this fucking cell phone. We had to use our hands to call people. We didn't have no chip embedded in our heads. We had no chip that we could call just like, hey mom, how you doing? And then fucking mom's face pops up in your memory. And you see her live in your memory because there's a fucking TV screen in your mental whiteboard from your fucking Intel chip that you've got inserted into the base of your skull. No telling what's gonna happen in fucking 25 years. Your kids are gonna be fucking monsters. You're gonna know some shit, you're like, nope, that shit didn't exist. I don't know, I can't help you. I don't have no chip in my head, son. Fucking ready to roll your eyes now, but you wait. There was no fucking handheld gaming device. That shit didn't exist. Well, no, Game Boy was out by then. So it's they probably updated from the way they did cameras. I don't know how they figured out cameras. The way they used to do cameras is they fucking had the fucking black carpet over the lens, and you pulled the carpet up so you blocked out as much as light as possible, and you quickly slid a fucking shutter and closed it. This is beyond my time. I'm not that fucking old, but I've seen the cameras of old time. They slid the fucking lens as quickly as they possible to let the image in once. And that processed a photograph. How the fuck they figured out to put some paper behind that with some fucking chemicals on it to make that work, I have no idea. But once that was figured out, having tech do the same thing just has it record the color that comes in at a particular cell on a sensor, I would guess. Once you even thought to do a photograph. All right, so we do our sub here. We're going to do both ways. I'm going to do the substitution first. So if x equals e, u equals natural log of e, which is what? It's 1. If x equals e squared, u equals natural log of e squared, which equals what?
2.
2. The quick way is to bring the power down. Remember your logarithm properties. So that really sets up an easy change of integrals to new limits. And we've got u, and u equal ln x, and that just ate up my dx. That became du, and this becomes a really easy problem. Now, if you stick with the old ways, we have to keep x equals e and x equals e squared. We still have u du. Here we go, up a power, divide by the power, evaluate from 1 to 2. And we have 1/2 2 squared minus 1 squared. I like to leave the 1/2 out. You don't have to do that. You can also do 1/2 2 squared minus 1/2 1 squared. That's entirely reasonable. A lot of students like doing that, but I think you end up with more work here. And like the fractions, you got to deal with fractions more of the way. It's almost always easier to do the multiplier last. This is 4 minus 1 is 3 times 1/2 is 3/2. We do this over here. I've got 1/2 natural log of e squared minus natural log of e. Squared. The trade-off, this, like the green was clearly longer, unless you factor in the time it took to do that. Again, on your test, you're gonna be asked to do one of the problems both ways. But a couple of them, I leave it up for grabs. I let you do whatever you want. So pick the method you like best. This is the hardest one to get used to doing, at least it was for me. I did not want to do it. I kept I kept doing the revert back to this. But as soon as I forced myself to do this a bunch of times, I realized it's not that bad, and getting used to doing these changes, these limits, will help you a lot in later classes. Because this just gets harder and harder, and you don't want to plug shit back into a harder function. Preston.
Right, so basically, when you substitute like that, you basically just want your substitution derivative to match up with the original derivative, kind of. Like you did, like your x is like d of x, and then your du kind of like match. Or you basically just like rewrote it.
Yeah.
Yeah.
Here I rewrote, like here we changed to u, but I also changed the limits to u.
No, I'm talking about like way earlier.
Way earlier.
Like when you substituted. And then you took its derivative, right?
Yeah.
You basically wanted it to be the same, so that you could just rewrite it. To be u.
Yeah.
To be u and
The other option you have, some students like doing it the other way, but I think if you get used to doing it like this, you'll find it saves you time. But the other way of looking at that, let's go back to it real quick. And saying dx equals x du. And then you have to, when you plug this in, I've got u over x times x du. And now the x's cancel. And we still end up getting that.
Yep.
But this gets ugly, this is uglier. You guys ready for another? Like if this is the end game kind of stuff, and this, I got a couple more for you. What would make a good U sub here? Or do we need a U sub? It's always worth penciling out your options. If we don't use sub, if we say no sub, I need to distribute. And I've got 3e to the x minus 4e to the 2x dx.
Screen frozen.
Oh. So there I just distributed. E to the x times e to the x is e to the 2x. It looks like we'll still need a sub for that. So I don't know that we're saving any time by waiting to do the sub. In fact, this one would need a sub, this one wouldn't. So we would have to do it separately.
How would you know? So,
Do you know the integral of e to the 2x? There you go.
also don't know the integral of the first one. So there's that.
Right. But do you know the integral of e to the x? So there's parts we do know. So what part do you not know? What part looks like a pain in the ass? Like all of it together looks like a pain in the ass, right? What could I do at U sub 4 here?
Side. Side of parentheses.
You wanna do the whole thing? Sure, let's do it. Can't hurt to try, right? That's not bad, because we've got e to the x dx right there. I just need to move the -4 over. Let me make this -1/4 du equals e to the x dx. And now I can see that there, and I think we got a good sub there. If I do that, what happens to my limits? X equals 0, I'm going to u equals 3 minus 4e to the 0. E to the 0 is what? 1. So we got 3 minus 4 times 1 is -1. If I do ln of 5, I got 3 minus 4e to the ln of 5. What is e to the ln of 5? That actually has a shortcut too. E and natural log are inverses. That just becomes 3 minus 4 times the argument of the natural log. 3 minus 4 times 5. So this will be -17. So I could redo my limits as -1 to -17. I have -1/4 du there. That was my e to the x dx. And then I just have u. So -1 to -17, -1/4 u du. Or if we wanted to put them in the proper order, -1 is actually more than -17. So if we want to put them in the proper order, what do I got to do? Does anyone remember what happens when we change the order? We just introduced a negative. That's right, Dalton. We make it a negative. We still had a negative here. So this would become -17 to -1, a positive 1/4 u du. I'm missing a u there. Now I don't know why that camera thing popped in my head. The cell phone thing. Now I feel old as fuck. It ain't been that goddamn long. Not on the grand scheme of things. 25 years for one person's life. That's over half my life. I'm not over 50, despite how wise I am. All right. Either one we integrate, I'll do this one. -1/4, we go up a power, divide by a power would be that. -1 to -17. Or we've got 1/4 times 1/2 u squared, -17 to -1. Which is interesting. Because the u squared is going to make part of this go away. Are these equal? Let's check it out. I've got -17 squared minus -1 squared. $170 and then 70 and then 49. 289? 17 squared 289? It might be. Oh, trusty calculator, where are you? It is 289. Look at that. Minus 1. So negative 288 over 8. Do I get the same thing with this one? 1/8 of negative 1 squared minus negative 17 squared. Yep. Now, I'm sure this reduces. They're at least both divisible by 4, I can see that. If I divide by 4, this is 72 over 2. That actually divides even further. This should condense down to negative 36. Yeah,
You swap the order of.
by introducing a negative sign.
No, I know how you do, I'm just wondering why. I don't just stick with just-
You can.
Oh, okay.
Sometimes you don't want to. And I was just reminding you guys that you can do it. Some teachers will get really, really fucking picky. And be like, you gotta integrate in the right order, it's gotta go from low to high. And like try and force you to fucking swap. But if you do it correctly, the answer is the same. So that's just being picky. Right? The answer is the same, it's just being picky. All right, you want one more? Do it. Let's bring the thunder. Oh. -1 to 4 of x over the square root of 5 plus x dx. Any ideas here? Any ideas? Let's try the denominator, see if that helps us. It might, not as I intended though, or we've got 2 du equals 1 over the square root of x plus 5 dx. I actually see that here. We have that right here. But I don't have a square root of 5 plus x up here. But maybe I could get it, maybe I could write this in terms of x. If I square both sides, I've got x equals u squared minus 5. So I could write this as u squared minus 5 du. And my limits would be when x equals -1, u equals -4. When x equals 4. No, I got this. This is, no, I'm doing this the wrong way. I'm plugging into the wrong thing. I need to plug in up here. When x equals -1, u equals 5 minus 1 is 4, square root of 4 is 2. And when I plug in 4, u equals square root of 5 plus 4 is 3. And I'm missing a 2 here. I'll put the 2 out front. And my new limits would be 2 to 3. If we go up a power and divide by a power, that's 1/3 u cubed minus 5u. Evaluate from 2 to 3.
With the two.
When I replace the 1 over square root of x plus 5 dx, I replace it with a 2 du. And I move the 2 up front. That make sense? This step is actually the step where a lot of students make the most mistakes. You're like, I'm at the end, and you don't fucking take your time to write it down all down patiently. And do the order of operation. There's a lot of order of operation shit going on right here. This is 1/3 times 27, which is 9, minus 15. Minus 1/3 times 8 minus 10. If I distribute the negative here, I have minus 8/3 plus 10. In particular, that is the thing that is missed most often. Students don't distribute the negative to both things on the second half. It's an easy one to miss. If you don't put in parentheses, you're gonna miss it. Fuck, even if you put in parentheses, you still might miss it. I know I do. I get hasty. Let's see what we got going on here. I've got the 2 is still up front. If I add the 9 and the 10, I get 19. And then 19 minus 15 is 4. So there I just got all the constants together. If I get a common denominator here, I can multiply that by 3 over 3. Three times 4/3 is 8/3. So that's a tricky one. Right? Look very tricky. Another valid sub would have been. Would have just been u equals x plus 5. So that du equals dx. And here, this becomes x equals u minus 5. When I do x equals -1, u equals 4. When I do x equals 4, u equals 9. And the integral becomes 4 to 9 of u minus 5 over the square root of u du. Which you can break up into, just divide, this is exponents, u to the 1/2 minus 5u to the -1/2 du. And that's how you integrate from there. And you'll still get the 8/3. So sometimes there's more than one way to skin the cat. And if you're a cat lover, sorry. That's an expression I picked up from my mom and I've never gotten rid of. And it sucked because I've had a couple semesters where I said that and a student just started bawling because their cat had just died. And I'm like, oh, that's fucked. I feel bad, but it still keeps coming out of my mouth. So Jose, we had u equals square root of 5 plus x. I solved for x here. I squared both sides. And then I subtracted 5. Does that make sense? Have a good day. The review's up. I will see you guys on Tuesday. As a reminder, I'm in the Mesa Center, 9 to 12 on Saturday. If you want to come in and get your last minute study or questions on with me, I'm more than happy to help. I don't bite.